Good morning, everyone. Welcome to our panel event on the AI Hype Cycle, taking stock of where we are. This event is hosted by the TD Management and Analytics Lab at the Rotman School of Management. My name is Ryan Webb. I'm a professor of marketing and academic director of the Data Lab. Although we are meeting virtually, we wish to acknowledge the land on which the University of Toronto operates. For thousands of years, this has been the traditional land of the Huron-Wendat, the Seneca, and most recently the Mississaugas of the Credit. Today, this meeting place is still home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work on this land. So we have an expert panel today ready to share their insider knowledge about the power of AI and its impact across different industries and markets. Our goal for this event is to help you understand industry trends and help identify technologies that add value versus those that are more speculative in nature. I know this will be a fantastic discussion, so I'm excited to jump in. So let's begin by introducing our panel today, beginning with our moderator, Brian Keng. So Brian is research director at Borealis AI and an adjunct professor of data science here at the Rotman School. At Borealis, Brian leads the incubator program, building out innovative AI-enabled products for the financial services industry. At Rotman, he plays a key role in shaping data science education and research throughout his work with the Data Lab and our Masters of Management Analytics program. So welcome, Brian. Next, we have Waleed Ayoub. Waleed is the Senior Vice President of Solutions at Kinaxis Incorporated. He is a product and technology leader with nearly 20 years of hands-on experience empowering talented teams and building impactful enterprise products. Waleed specializes in transforming data and machine learning from an operational afterthought to a revenue-generative asset for the world's largest enterprises. So welcome, Waleed. Next, we have Foteini Agrafioti. Foteini is the head of Borealis AI and chief science officer at the Royal Bank of Canada. She is responsible for RBC's intellectual property portfolio in the fields of artificial intelligence and machine learning. Foteini serves as co-chair of the Advisory Council on Artificial Intelligence, advising the federal government on how to build on Canada's strengths and global leadership in AI. So welcome, Foteini. Next, we have Avi Goldfarb. Avi is a professor of marketing in the Rotman Chair in Artificial Intelligence and Healthcare at the Rotman School of Management, as well as the chief data scientist at the Creative Destruction Lab. You also saw his smiling picture there on the little video at the beginning of the... Avi's research focuses on the opportunities and challenges of the digital economy. He has published academic articles in marketing, statistics, law, management, medicine, political science, physics, computing, and economics. Avi testified before the U.S. Senate Judiciary Committee on competition and privacy in digital advertising, and he co-authored the best-selling book, Prediction Machines, The Simple Economics of Artificial Intelligence. So welcome, Avi. And finally, we have Nick Howard. Nicholas is the Senior Vice President of Technology at Assurance IQ. He started his career in the U.S. Army as an infantry officer, earning 2 Bronze Stars, and then served as a professor of mathematics at the United States Military Academy. After leaving the Army, he entered the tech world with startups in the healthcare and supply chain industries. He currently leads a team of over 150 engineers, product managers, and data scientists to support the business and drive innovation throughout Assurance IQ. So welcome to all of our panelists. Before we begin, I have 2 procedural notes. At any time, if our audience members have a question for our panel, please go to slido.com and enter the code AI Hype Cycle, hashtag AI Hype Cycle. The link to submit questions can also be found on the description in YouTube. Our staff will share the questions with the panel near the end of the session during the Q&A if time permits. And this YouTube link will be accessible for 14 days after today. So now, Brian, over to you for the panel.
Great, thanks, Brian. So before we begin the panel, I want to just give a little bit of introduction to the topic that we're talking about. It's really around this hype cycle, or where the expectations around this technology AI don't meet reality. And to do that, I want to take us back to really the birth of AI and some of its history, because this pattern of the expectations of AI not meeting reality has really come up multiple times. Now, taking a look back when AI was born in the 1950s, this was a time when computers weren't really much more powerful than your pocket calculator. And at this time, this new technology, these techniques of AI just captured everyone's imagination about what it could do, from automatically solving math equations to building these robots that could do these tasks themselves, to even the first forms of these primitive chatbots that they had back in the day. And so there was a lot of investment and interest into this technology at the time. and probably a little bit too much optimism about what it could do, extrapolating beyond what the technology has really shown that it could produce. And to just give everyone a sense of how optimistic folks were, I pulled a few quotes from some of the most prominent researchers at the time. And so these aren't just laymen who didn't really understand the technology. These are people who are developing the technology at the time. Let's just go through them. So in 1958, Simon and Newell claimed that within 10 years, a digital computer will be the world's chess champion. So that did end up happening, but that ended up happening 40 years later. In 1965, Simon was quoted as saying, "Machines will be capable within 20 years of doing any work a man can do." We're in 2022, and still that's not quite the case. In 1967, Marvin Minsky said that within a generation, the problem of creating artificial intelligence will substantially be solved. Of course, that's not true. There's still a lot of investment and a lot of problems that we haven't figured out. And then Minsky also said in 1970, in from 3 to 8 years, we will have a machine with the general intelligence of an average human being. And unless we think very lowly of our fellow human being, we are so far away from this goal as well. And so this is kind of showing you the first signs of this idea of AI capturing people's imaginations and really propelling their optimism or their expectations of what it can do far beyond what the technology can deliver. And so throughout the up to the 70s, this was kind of the feeling and the ideas that people had. But starting somewhere in the 70s, AI started really hitting the wall, hitting reality of what it could deliver. The techniques that had been developed up to that point really were hitting limitations about how complex a problem they could solve. Really, they could only solve relatively simple problems. Partly it was the techniques they used and the inherent limitations they had, but partly was also the very limited computational power that we had at the time. And so what was known as the first AI winter happened around between 1974 and 1980. And AI investment dried up. A lot of research pivoted out of AI because it just wasn't a hot topic, and it was kind of accepted that these techniques wouldn't be useful. The interesting thing is that that didn't last for that long. Starting in the 80s, this new technology of what's called expert systems came about, where we were hoping that we could encode all of the facts that a human knows, say a doctor, into a system so that it could reason, it could aid, and maybe take over some of the job of some of the professionals that we have, take over jobs of humans. And so again, this idea of artificial intelligence taking over and being able to provide new innovative solutions came into play, and a lot of investment went into AI around that time. But as a pattern that we're seeing, that optimism about AI hit a wall again, and it was not able to deliver because of the inherent complexity and the inability of those types of systems to reason on anything outside of their very limited domain. And so the second AI winter around the late 80s into the 90s happened again, where funding dried up. A lot of these techniques that were hailed as the panacea to solving AI really fell by the wayside. And so the second AI winter happened. Now, interestingly enough, as we kind of look into the 90s, a lot of new developments were happening. And the interesting thing here is in the 90s and into the 2000s, that these developments weren't broadly categorized as AI. Perhaps the researchers and the companies found out that maybe this isn't the right word to use, and maybe it's just the separate branches of AI started developing their own personas. However, that changed, coming up on 2010 with this advent of deep learning. So this is using neural networks essentially to solve problems that we thought computers were just not very good at. And this was powered by a lot of the massive amounts of computational power that we've developed thus far, as well as the massive amounts of data. And so from around 2010 to right now, there's been so much investment in this technology called deep learning, and has really propelled this idea of AI to go beyond what we thought was possible since its inception. So things like, especially in things like computer vision and natural language text, it's really advanced beyond what we could have dreamed of even 15 or 20 years ago. So for example, in certain specific cases, AIs can now diagnose images better than doctors. In other cases, this has just happened this year, OpenAI's DALL-E 2 will allow you to enter a text prompt that might describe an image, and it will come up with new and creative, very high fidelity images of whatever that text prompt was, kind of foraying into the realm of art. And so the question that we want to talk about here today is that all this investment, all this optimism, this newfound optimism about what AI, in particular this deep learning, can do, is it justified? Is it going to hit a reality wall? And one of the great frameworks by Gartner is this idea of a hype cycle. And so this really follows what AI has been seeing over its lifespan. The idea is that when a new technology comes out, people get really excited about it, and its expectations go through the roof. And those expectations naturally don't match reality. And after a while, people realize that, and what happens is that the technologies fall into this trough of disillusionment. At some point in the future, technologies come out of that trough of disillusionment, and they find some kind of plateau where the expectations do meet the reality. So the question that we have here today, and according to Gartner, some of the core technologies in AI, AI cloud services, deep learning, natural language processing, machine learning, have come off their peak expectations. And so the question that we want to understand today is, are these technologies going to fall into a very deep trough of disillusionment, or are they going to quickly level off and plateau in terms of the expectations and the investment into them compared to what they can actually deliver? Okay, so that is the quick intro that I have. And so I think we can start the panel, so we can bring the panelists back up. I'm so glad that we're able to arrange all these great folks today. And it's good to see you all again. So to start off the panel, the first question I have is a general one. What areas are you investing in AI today? So maybe we can start with Waleed. He is kind of an expert on the supply chain side, working for Kinaxis. And 2 years into the pandemic, we're still thinking about supply chain. So Waleed, what's your take on this?
Thanks, Brian, and great intro. I think that Gartner Hype Cycle read is really good, and I think everybody should take a look at it. So from my perspective, in terms of areas of investment, so keep in mind that Kinaxis is like a 20-plus-year-old supply chain software company, and we power supply chain planning for sort of Fortune 100, Fortune 500 companies across the world. And so we've been investing in the broad umbrella of AI for a very, very long time. Primarily that expert system piece that you talked about, sort of a balance between trying to solve problems either really fast or really accurately, right? So that's the balance that we try to find. And in order for us to solve things really fast, traditionally you're using very, very complicated heuristics that are hand-tuned, hand-coded based on experts who understand the space really well. So that's the primary area where we invest the bulk of our sort of AI investment, if you want to call it that. And more recently, we've started to, there's actually a dot on that AI hype cycle called composite AI. The idea that the future isn't necessarily about making one algorithm better, but the agglomeration of a bunch of things together that produces a better solution at the end point. So more recently, composite AI has been the vision and strategy, and we've been bringing in ML, we've been bringing in integer programming and other type of sort of constraint-based optimization approaches in order to solve that the problems that we solve, which is basically how do you balance demand and supply in real time with a whole bunch of constraints across a very complicated network of raw materials, goods, logistics, trucks, warehouses, stores, you name it. So that's the primary area from like an AI investment. And then sort of as a parallel track, explainability and insight is another area where we're spending a lot of time and effort. And that doesn't mean it's like an AI problem, but it's really that sort of surface on top of the AI that people are asking a lot more about in terms of, well, tell us how these machines work, tell us what they're doing so that we can explain it to our stakeholders in order to get a better sense of where we as humans should override the system. So that's kind of the other sort of umbrella area where we invest a lot.
Yeah, that's really interesting. I think the composite AI is something that I'm kind of really excited about. And I feel like one of the ideas is that it gets over this man with a hammer syndrome, where you have one algorithm to do everything. Let's turn over to Foteini. I mean, part of RBC, Canada's largest bank, and one of the largest employers. There must be a lot of another interesting view that you have on this.
Good morning, and thanks for having me. Indeed, Brian, so across the enterprise, there are, I think we had measured at some point, there's over 3,000 models that make automated decisions on behalf of our clients every day. And naturally, there are data science and AI teams working from spaces like cybersecurity to fraud detection, risk modeling. Within Borealis AI, which is the R&D arm of RBC, if you may, there are 3 areas where we are primarily focused today. And it's been a journey to get to this. And I'm happy to chat about how we first attempted AI research at the bank and how we got to where we are today. But where we are is, number 1, time series modeling. This is a space that is very relevant to financial services because of the nature of financial markets. So we've got a large group dedicated to understanding trading dynamics. We look at problems like return predictions, equity trading, things where you're building models that can take actions, but every action changes the market once that happens. And so you got to remodel your environment every time you take a new action. Very complex environment. The second area of investment is in personalization. And this pertains more to our retail bank. And so understanding how our retail clients, consumers are spending their money, how they're using their credit cards, how they're planning for large purchases in the future. There are some really interesting problems there around understanding what really one's wallet is like. So understanding their cash flow when there's so much asynchronous events that are happening. So unlike capital markets where you're trading and there's every tick, you got a bunch of data from the market. In the retail bank, you got people using their credit card 5 times a day. Then they don't use it for 5 days, and they may use it once. And so it's very asynchronous data, and that presents interesting challenges from a machine learning perspective. And finally, we're also looking at credit. It's, of course, the backbone of any banking business. Lending is one area that is super prime for data analytics, and we've been able to bring state-of-the-art machine learning models to it. And so adjudication, understanding how much credit one person can take on. Are they able to take on credit, first of all, and then how much? And so there's very interesting problems there also because it is a very regulated space. And so it requires an immense amount of scrutiny that you apply on these systems in terms of bias, robustness, and explainability. And that's an area where Borealis is very actively researching in as well. That's it in a nutshell. There's 3 main areas of investment.
Yeah, thanks. And we'll come back to that idea of robustness or quality or responsible AI. I think that's a really interesting topic. But one thing I really liked about the 3 areas that you talked about is that they aren't the headline areas that consumer internet companies always put in your face about computer vision or speech. And there are like a lot of really important problems that we're solving that are not really those headline problems that are really backbone of our economy. Maybe turning to Nick, kind of in pivoting from the banks to insurance. I know that you have a lot of a big data science team and are doing a lot of practical problems around there. Where are you investing in AI?
Yeah, it's interesting. Thanks, Brian. So Assurance IQ is a consumer insurance marketplace based in the US. We do very large scale. And our primary sort of business problem that we're often trying to solve is somebody's come to our website and indicated some sort of interest in an insurance product. How should we now engage with them? Like that's, the simplest business question that we have. But at the scale that we're at, we do over 1 million outbound dials a day, probably 4 or 5 million emails, a few 100,000 texts. So from that perspective, there's a few key areas that we're really starting to drive into. Historically, we've used a lot of machine learning prediction around optimizing the timing of outreach with consumers and trying to understand if somebody wants a digital experience or if somebody wants to talk to an agent on a phone, right? We've just rebuilt most of our outreach service to be a true omni-channel service where you can intelligently interleave SMS, email, web chat, and dialing, right, into one coherent conversation with a consumer. And so we're actually investing really heavily in getting a lot smarter around this. And so our data science team is looking to try to predict, like, hey, we tried to call you, you didn't answer. What's next? What should we do? Should we engage in another channel? Should we wait? Should we follow up? Are you still engaged on the website? And so really understanding where somebody is in their purchase journey. Are you just looking for educational material? You're not ready to make a purchase? All those sorts of questions, which I think you could broadly describe as sort of personalization. But we have over 100,000 leads coming in per day, and so doing it at scale is occasionally challenging. Another area that at our scale is actually really important to us. We're to the point where we're building custom answering machine detection algorithms. Basically, we found that the off-the-shelf ones that most of the telephony providers have are insufficient. And we've made some significant advances there between our data scientists and our engineers that have led to about a 10x decrease in false positives, which is pretty transformative from a workforce utilization perspective. Another really big area, we do a lot of product recommendation, right? It's one of our core competencies. We do it in a very bespoke way because I would say most recommendation sort of approaches are what I call, big data, like really wisdom of the crowds, right? Like we have a ton of products, we have a ton of people. I don't really know who Nick Howard is and I have no clue what he wants, but I know that people who look like him bought these things, right? The challenge for us is somebody comes to us, they answer like 4 questions online. That's all the information we have. We have no ongoing relationship with them. And we then have to select between maybe 20 distinct insurance products. And so it's not a big data problem to us. And so we actually reason about it from a first principles perspective of what are the features of this product? What do we believe your needs are? How do we put those together? The challenge that some other people have mentioned is the explainability. And it's in 2 ways, actually. So over 90% of our sales go through an agent on the phone selling insurance to a consumer. And so we are making a lot of investments, as Waleed said, like it's not distinctly an AI problem, but like how do we change the UI and the user experience to help an agent describe why this is the right product for you, which has huge impacts to the consumers. If the agent sells them the wrong product, they almost always cancel it. It's bad for the consumer, it's bad for us. So changing the product experience there, but then also if you're buying digitally, how do we do that? And the interesting thing is that our data scientists have always thought very deeply about like, why are we making this? Can I defend this? We are in a regulated industry. If the New York Department of Financial Services asks us, why did you recommend this product? We have to be very comfortable explaining why. And so we've got that. But what we haven't thought about is, how do I take the log data that a data scientist can interpret and make sense of and answer questions if they have to, and turn it into a series of like distinct sentences or reasons that we can put in front of a human being that doesn't understand the algorithm at all to give them confidence in it. And so it's not, there's the product and the user experience side, but also our data scientists are starting to think a little bit about, my AUC is like, I get a small bump there, but I don't know that I can explain that to somebody. And therefore, if people don't trust the recommendation, then it doesn't matter if it's more accurate, right? And so I think we're starting to change how we're thinking about model accuracy and model quality from that perspective.
Interesting. Yeah, I like kind of 2 of the themes that are coming up there. One is that the explainability and the need to actually integrate it into the overall business and not just kind of in isolation. And then the other thing is, like, I feel like we're getting a good sample of things, like from kind of more of the back office or back end things from supply chain and some of the bank functions to kind of more marketing and sales and more consumer facing approaches. So thanks for that view. Maybe we'll turn to Avi, because you see a lot of, this is kind of on the other end of the spectrum with much smaller companies. You see a lot of ventures coming through Creative Destruction Lab. What are some of the themes you're seeing in terms of investment recently?
Okay. Excuse me. Let's open with, we just heard a whole bunch of great applications of AI. And those are a lot like the companies that we saw in the Creative Destruction Lab for the first 5 years of our program in AI, like 2015, 16, and maybe even through today. So what they are is they are point solutions for a particular problem that a company has to service a particular decision. The decision is already happening. It's not like the AI is enabling new kinds of decisions. It's, hey, we have a decision. Maybe we were already using machine prediction before, but the machine prediction might have been good old-fashioned stats. And now we're using a handful of new tools and doing it much, much better than we were before. And so I think there's been a great advances over the past, I guess, decade, maybe in total, in CDL not quite that long, on these point solutions using AI. I think we are starting to hit diminishing returns to point solutions in most organizations. So when you found the predictions you're already making, and you're doing those better, and you're servicing the decisions that incrementally increased productivity, made the companies a little bit better off, and found some real uses. But for the most part, these point solutions aren't creating new industries. And for the most part, these point solutions aren't transforming the way the organization operates. The data scientists still aren't running the company. The data scientists are still a part of the company that serves some other goal. And what I think the next stage is going to be to identify when better, faster, cheaper prediction, and what we have with the current generation of AI, enables new systems of solutions. So when we start thinking about, can we serve our mission better overall and restructure the organization in some way? So, in the insurance industry, for example, Nick, to pick on you a little bit, although you're on the matching side, not on the insurance side, right? So we have underwriting makes a prediction of, okay, here's your risk. And then that's all you know. Like, can you imagine going to the doctor and the doctor says, okay, you have a 10% chance of dying in the next year. And then you say, well, why? And I'm like, I don't know. That's just what the number is, and I can price it. That's just not useful. And so, but you can imagine insurance, if the predictions are good enough and you can predict at the sub-peril level, for example, and really know, hey, this person is going, has a 15% chance of having an electrical fire, then you can offer solutions that's different from the traditional insurance industry and start to rethink what insurance really means. And you can imagine the same kinds of ideas at RBC in terms of thinking about, oh, well, let's go beyond predicting the time series and try to think through how we can redesign our customer experience in order to better serve the mission of, not sure what RBC's mission is exactly, but helping people manage their money better. And in the supply chain industry, it could be a lot less reactionary and a lot more proactive. Like in prediction machines, we talked about this idea that Amazon could move from waiting. Right now, they're a recommendation engine. That's where their core prediction is. And then they send that recommendation to a warehouse and they ship it to your door. With better, faster, cheaper prediction, we get companies like Stitch Fix. With better, faster, cheaper prediction, we move toward a different system where instead of waiting for you to order, they have a good prediction about what you want and ship it to your door right away. Now, that's not a totally new industry. For those of you who are of a certain age, you may remember that's what Columbia House Records did in the 1970s, because they knew what the pop album that you wanted to hear was. It was the same one for everybody every month. The prediction was really easy. There was no machine learning involved, and they could just send you the #1 pop album every month and you'd be done. Now with Spotify, we can do that same kind of exercise at a much more personalized level, at a moment to moment, rather than month to month basis. And so what we get is better, faster, cheaper prediction, enabling these new kinds of systems. Problem is that's hard. Okay, so we've got the point solutions. We're trying to understand that. We can see this future someday where we're going to have these new systems in various industries that are, that involve a whole bunch of complementary investments to machine learning, to prediction technology. And we heard a little bit about that in terms of, optimization techniques and expert systems and robotics. All of these are complements to prediction. But right now we're in the between times. Right now we see the potential of the technology, but it hasn't really transformed very many industries yet. But it's probably coming for you in insurance, and it's probably coming for you in banking, and it's probably coming for you in supply chain. It's just a matter of thinking through how and why.
Brian, you mind if I respond with a couple of thoughts there?
Sure, go ahead.
So Avi, your point on sort of the point predictions, I think is very well taken. And I think when I think about hype around AI, I think people still believe that there's some generalizable solution. And when I say people, like, I'm actually thinking, if I'm being honest, a large number of senior execs at Prudential who acquired us a few years back, that they just don't understand it. And they think like, oh, well, you guys built this, so we can just apply it across all of Prudential. It's like, no, that's not the way it works. Your point as well, though, on just doing that doesn't help. You have to transform the organization. I totally agree. And actually, your point on data science doesn't run our company, I'll take issue with, because our CEO is our former chief data scientist, and our data science department has more influence in our org than any other organization, which sometimes frustrates the business and the marketing orgs, because a data scientist with 3 years out of undergrad can write a Confluence doc that gets our CEO's attention and changes the strategy of the company. And I think that's one of the reasons that Prudential acquired us, is they recognized that we had organized around that first and foremost. Your point on insurance personalization from the underwriting, I agree with you a million%. The thing that I see over and over is that the regulators have serious concern, particularly around bias, right? They're, at least in the US, the regulators are really freaking out around, are your algorithms racist? I mean, honestly, right? Like, particularly in life insurance, you look at mortality and you look at income, right? Or excuse me, health conditions and income predict mortality very well in the US, but those are so heavily correlated with, ethical, or excuse me, racial and sort of other boundary lines that people are scared.
So Nick, this isn't totally speculative. We are working with a major U.S. insurance company to try to make this happen. So we fully appreciate the regulatory.
So this is, if I can interrupt, this is great, because I want to come back to this idea of bias and fairness and responsible AI. But maybe before we get there, and like Avi, I really appreciate your comments, and it sounds like you are maybe a little bit more of an optimist on where this technology can go. So I want to kind of flip it around to this idea of this hype cycle. Is what areas are you pessimistic that AI will deliver on in the short to medium term?
Is that for any?
Avi.
Okay, I'll start with that.
Yeah.
These are prediction machines. They're not causal inference machines. And so the biggest mistake I see in business applications is a failure to recognize that that the data come from a decision-making process, and you need to understand the humans who make the decisions in order to use it effectively. And so sometimes they are pure prediction problems, and in those cases, an AI using machine learning tools is fantastic. And sometimes you're trying to change behavior, which means you need to understand causal inference, which is a very useful statistical toolkit, but it's a different, or at least it's a complementary statistical toolkit. And so where I've seen the biggest failures so far, and I expect them over the short term, is when people fail to think that they're dealing with a prediction problem when they're dealing with a causal inference problem.
Very interesting. Foteini, same question to you. What are you pessimistic about? And the interesting thing is, I know we've been doing a little bit of work in causal inference. I'm not sure if you have any comments on that, and then other general technologies you're more pessimistic on.
I share a bit of the concern around causality, that it is a very exciting field, and one that I think is worth further investing in. I would say another one that has perhaps let me down is the field of conversational agents and language processing for human-like communication. So anything that goes beyond FAQ answering to a conversation that is completely free, unscripted, and can diverge into any topic. I find that not only the science hasn't really got us there, but also the practicalities of and the realities of a lot of the businesses that we're looking to adopt technologies like this. So a doctor in a box, a banker in a box. Like we used a lawyer in a box. We heard a lot about boxed professionals in the beginning of the cycle. And in many cases, it's not just that the science wasn't there. There's a level of a personality that a human brings to that interaction. There's a sensitive nature in talking to your doctor, talking to your banker about your mortgage, your ability to send your kids to school, that I simply don't think that AI, we don't understand how we're going to get there. But it's not broadly understood that this is where that science is today, actually. People still think that you can build these professionals in boxed professionals.
That's an interesting point, just because on that hype cycle diagram I showed, and Gartner puts chatbots in the trough of disillusionment, because I know like a few years ago that was really all of the hype. Some people may not have seen the most recent Gartner hype cycle. Nick, I know that probably hits home for you because that's a lot of what you do. Do you have a view on where on this and maybe where other places you might be pessimistic on?
So this is the number one area where we're investing, and I'm pessimistic, is around NLP. Like we have a ton of use cases because we talk to people all day on the phone and engage with them, as I sort of shared. We're getting into it, but I think there's a couple things. Like transcription of voice is a relatively commoditized entity right now, in my opinion, and no one is nearly as good as they claim. So you're dealing with a messy transcription, and then you're processing that text. And I mean, not just for our own, but I've talked to a lot of other data scientists working on problems like automated underwriting and these sorts of things. And like everybody boils it down to regex at the end of the day. It's an insane amount of domain specific knowledge with regex searches. And like, yeah, maybe you do, some really simple like statistical analysis of different things, but it's, I don't know anyone that's doing these problems that would even pretend to another colleague that they have solved it, right? I think the only place that you see that is when you're talking to an investor or to try to get fundraising, in which case they only want to hear that it's fully generalizable. That's generally been my perspective.
It's interesting. And it's interesting because all of this relates to kind of natural language interactions with humans, which is obviously, one of the hardest parts. Waleed, I'm interested to hear, do you have any similar perspective? I know supply chain maybe is not so close to text and
yeah, I'm coming from the cold hard world of trying to optimize supply chains, right? So the conversation around chatbots and just NLP, although it's an area that we sort of look at from a distance, it's not an area that we invest today, and I don't know if it's an area that we are looking to invest in. But so there are a couple of areas that I think we haven't touched when it comes to the pessimism lens, let's say. I'm generally not a pessimistic person, nor have I ever had lofty expectations for AI to begin with. So I'm kind of the cop-out. It's like I never really thought AGI was going to be a thing that we can really get to in decades, let alone less than that. But the two areas I would talk about, one is labor, the implications on labor. So this whole idea of a thing in a box, we don't sort of subscribe to that. We build software that allows planners, so supply chain planners, demand planners, in manufacturing and retail contexts, to basically automate a lot of the things that they would otherwise have been doing themselves, right? Generating forecasts, sort of manually tuning constraints when they're trying to figure out how to balance an order or something like that based on a whole bunch of incoming information. So we do provide that level of automation. And where I'm most pessimistic is that we don't sort of have a collective understanding of how labor will function in the presence of a lot more automation. And I believe that has as much or more downside or potential sort of negative impact as some of the things around biases in data or in certain processes that affect, things like class rates, et cetera. And then the other thing is on the sustainability front, especially in supply chain. I don't know if this is necessarily true. I mean, I guess it is true for language models that require very, very, very expensive infrastructure and compute to run. Is what is the implication of these systems on the sustainability of the planet, right? Like we need the Cambrian explosion in hardware has probably been the biggest enabler of the moment we're in today. And the downside of that is where's all the energy going to come from to power these machines? So those are the other two areas from a pessimism / I don't know what's going to happen lens that I would add to sort of the lofty expectations around language models, vision models, and bias inherent in data models, et cetera.
Yeah, thanks for that. And like, it's interesting, even in such a different field, I think the interaction, that really point where the system interacts with humans, seems to be like one of the places where AI, I think historically, but also even with today's kind of techniques, really hits a wall, or at least is probably the most difficult part. And at least that's been my experience as well. Now, maybe shifting towards a topic that has come up again is this idea of responsible AI. And so it covers a lot of things, from bias and fairness of these algorithms, especially as they interact with human systems, all the way down to kind of more specific techniques, whether that's around model interpretability or even evaluation of the models. So I'm curious, like, where are we investing in those technologies today? And maybe since Nick and Avi already talked about it a little bit, let's go to Foteini first, because I know we have a reasonable investment in this area of responsible AI.
Thanks, Brian. Sorry. I think one of the most prominent, sorry, do you guys get my echo?
There's a little bit of echo.
Is it okay now? Yeah.
Yeah, I think so.
Okay, sorry about that. So the areas where we're mostly interested in from a financial services perspective is in the time series domain, where we look at in automated trading systems. We're basically looking to ensure robustness of these algorithms in the market. So there's, of course, constraints in place by regulators, and we need to ensure that an algorithm always plays within those constraints. So although you want to have a fully automated AI, at the same time, you want to make sure that it's not able to go completely out of whack, if you may, and trade outside the rules that the market abides by. So that's number one. Explainability is actually key there as well. Like, people think of banking, and they think that explainability is important in places like credit primarily, but that's not always the case. When we're trading, it's an environment where we still need to be able to, when we do that on behalf of our clients used to call up the bank and say, "Can you explain to me why did you trade like that?" And we had a human on the other side that would literally justify the logic or how they tuned an algorithm to make that decision. Now, when we have completely automated systems in place, we needed to make sure that there is a legitimate answer to why an algorithm is making the decision it's making at any point in time. We had recently launched a product called Aiden, which uses reinforcement learning to make automated buy-sell decisions in the equities market in the States and Canada. And we had to ensure that there's a sister product to that. That's the insight version that sits in front of the client. And it's basically a second AI that tries to rationalize how the first AI is making a decision. As you know, explainability in this field is an open problem. Unfortunately, these algorithms are black boxes. And so we try to approximate and measure a level of explanation that would be acceptable by humans, our clients, by modeling with a second AI how the first AI makes decisions, and output a prediction about why it thinks under these market conditions, Aiden made a particular trade. And so it may even give you a ranked list of responses of like, most likely reason is this, second, like, it gave our clients a lot of relief. And it really helped us build trust as we brought deep learning for the first time in public trading markets in Canada. This was really a space, it was uncharted territory, and we worked with the regulators in the space to build out and bring this to life. But it was something that we had to ensure is there from the get-go, or it was completely turned down by our clients. So that was a starting point. For us, responsible AI, building with considerations around your clients. Unfortunately, it's not a nice to have. It's the need to have. It's the only way to go to market. We intentionally slow down many times because we have to solve for these problems in order for our products to be viable. First and foremost, because we've been in business for a very long time, and we're not in business because we have a banking license. It's because people allow us to bank their money, and we earn that right every day. And second, because we're regulated, and so there's literally no other way. This is why I think that a lot of innovation in this space will come from regulated industries. Companies that simply have to solve for these problems are probably going to be on the forefront of the solutions that will emerge.
Yeah, that's a really interesting point. It's the last one, because a lot of the, I guess, this generation technology has come from consumer internet companies. And but this idea of when AI is interacting with human systems, that requires a different level, a different standard. And maybe, it is some of these regulated industries that's really going to push it towards being accepted more widely by regulators and also by consumers. So I know, Nick, you were also talking about regulators, and insurance obviously is also a very regulated industry. What are your thoughts, and what are you thinking about investing in responsible AI?
For us, we don't have nearly, I would say, as interesting problems as Foteini described. The concept of the AI in front of the AI is a fascinating one. For us, it really is sort of similar to what Waleed was saying. It's like, we need to understand why we made a decision, and we need to give confidence to the person who's using that decision, right? And I think it's a little bit of a simpler use case, and I do really think like the data scientist needs to think about how they want to explain their algorithm in an automated way to feed a UI, and then we need product design to come in and sort of take that across the finish line to understand what's going on. But I think for us, it's actually less of an AI or a data science problem, and a lot more of a human behavior problem, and solving for the intersection of those.
Yeah, that's interesting. This area of responsible AI is even things like interpretability. It's interesting because it's not just a technology problem at this point, and it's not just the specialization of AI. You have, product designers, UI, UX, also, social scientists as well, and in terms of how to understand human behavior. Avi, you were also mentioning about some of these different problems. Like, what's your perspective based on some of the companies that you've seen?
This is a little broad. My perspective on what in particular?
Responsible AI, and like where do you think the investments are going in this based on companies you've seen?
Right. So I think there's real reasons to be worried about AI point solutions being biased. Okay. And the reason we should be worried is because the humans that those AI predictions are based on are also biased. And so there's reason for pessimism about AI because there's reason for pessimism about humans. Okay. So Marcia Gassemi, who was the University of Toronto computer science professor, she's now at MIT, when talking about bias in AI, she says, well, yeah, there's lots of reasons to worry that the AIs are biased, but humans are awful. And, at least with the AI, we can audit it. Okay, we can, she doesn't use the word audit because she's a computer scientist, but at least with the AI, we can figure out what's wrong and improve it. Okay, and so in that sense, I am pessimistic that the machines will be perfect, but I'm optimistic they'll be better than us. Okay. And so where does then what happens? Well, why is it hard to build a point solution? Because we can audit it and figure out that the machine is biased. We're going to say, we don't want the machine. Let's stick with the human. Who's really incentivized to stick with the human? The people who benefit from that human discrimination. And so what happens is, because of the, with point solutions, first, we're hesitant to adopt the AI because we know it's biased and humans were ambiguous. Second, the people making the decisions don't want to adopt a machine that's going to make them less powerful. Like, who would want that? That doesn't sound very appealing. And so I'm pessimistic about the use of AI to decrease bias in the short run when we think about it as a point solution. Okay. But, and this is an important but, I am very optimistic that AI can reduce bias. But to do so, we need to rethink the way decisions happen, and we need to rethink a little bit the regulatory environment. That's another example of a system change. So thinking through the short run, I'm a pessimist. We're hitting diminishing returns and things are hard with point solutions. In the long run, machine prediction should make us just better, much better at unbiased decision making. As long as the people who are coding the machines are people with values that we respect and want as a society. So this is another version of short-term point solution with reasons to worry, long-term system solution. I think there's great reason for optimism.
That's interesting. And again, kind of this theme comes up that it's really where AI starts being integrated into other systems, other specialties, whether that's kind of regulators, more thoughtful design of how they're actually going to be used in the overall system, not just, as you kind of point out, these point solutions. And then maybe lastly, Waleed, I know we talked a little bit before this. You had a bit of different take on responsible AI. I know you talked a little bit about interpretability, but maybe you can talk about how you're thinking about this area.
Yeah, I mean, from a, responsible, more so capitalize that in lowercase AI. I guess I've already talked a little bit about the implications on labor, the implications on the environment of the work that we do and how it scales. The other area where, especially Kinaxis, and this is hopefully bringing a perspective that's a little bit different than the areas that we're talking about today, is sustainability in the supply chain. So basically the interpretability and analytics and explainability to make observable the ways large organizations plan, moving things from points A to B to C, and what the actual impact on the environment is of doing that, and providing recommendations and visibility into how they could potentially reduce that. Right. So if we're basically a control plane or a control tower for the supply chains for some of the largest organizations in the world, is there an opportunity for us to actually be the observability plane for sustainability as it relates to supply chain? I can get kiwis and mangoes and stuff every day when I go to the grocery store. What is the actual impact and cost of doing something like that? And are there more responsible ways, let's say, of making that happen? And do we have an obligation basically to sort of share that with customers that we serve?
Yeah, that's really interesting. So it's almost the usage of AI kind of in a responsible way in order to help the broader society and have a net benefit. Very cool. So I'll just take a moment here to remind the audience that you can submit your questions through the Slido link. I think it should be in the YouTube description at the bottom. We're going to save 10 or 15 minutes at the end and answer some of your questions. So please do submit there, and I would be interested to hear what you have to say. So maybe the next question, kind of following along of this idea of this hype cycle where expectations are high and maybe the reality is low, is kind of on the flip side. I'm interested in what areas of AI are you currently not investing in but are really excited about? So things that you're excited about but you haven't yet invested in for whatever reason. I don't know. Maybe Nick, we can start with you. Do you have any ideas? Or what have you been thinking about lately?
So I'm sorry, I have a very unsatisfying answer here. I'm not saying that we have the best solutions, but I think for all of the key business problems we have where we've identified opportunity, we've made investments. NLP has been the last area that we're just now moving into because of pessimism about what it can return. And frankly, my number one concern and why we haven't done it sooner is the amount of labor that it's going to actually require to get some value out of it versus some other low-hanging fruit elsewhere. I mean, personally, I'm really excited about some of the reinforcement learning and some of the other deep learning methods that are out there, but I haven't really identified a use case in our business for those today. So
that's really interesting. And the interesting part that you kind of touched upon is that something that maybe particularly executives don't really take into account is how much investment it actually takes to build these systems, and not just by technologists sometimes by humans who are either manually labeling or have to operate these types of systems. Very cool. So Waleed, why don't we turn back to you? What are you not investing in today that you're still really that you're really excited about at the same time?
Yeah, so I'd break it up into two categories, like platform categories and then solution things. So solutions are, the algorithms that we write and we productize in order to solve business problems. Let's call it. This is where the domain of integer programming solvers, heuristics, ML kinds of lives, and then the platform places all the tooling that you need to ensure that you are hitting certain SLAs for the software that you build, right? And because we are a software development, product development company, we often have to sacrifice on solution quality in order to guarantee repeatability, scale, reproducibility, all the things that you expect when you show up to work, open a piece of software, and it just has to work. So in the platform category, I mentioned earlier that there's been like a Cambrian explosion in infrastructure. There's also been an equally large explosion in tooling. Like when I started in this space, 20 years ago, I basically had a mainframe, I had a Unix server, and I had SAS. Like those were the tools I had, and I just basically wrote scripts everywhere to connect. Like the connective tissue between all these systems was a bunch of scripts somewhere. But now there are like a long list of point applications for every part in that operational chain, from observability to the distribution of compute across nodes to you name it, right? There's like a ton of these things, and that's an area where we're investing, and we're investing even more. In areas where there isn't as much maturation in a particular sort of area, we build it. And in areas where there is a good set of vendors or tools to select from, we want to select that. In fact, Andreessen Horowitz publishes a really good report called the Data Infrastructure Ecosystem or something like that, where they essentially sort of have a reference architecture for data, for ML, for BI, and all the various tooling that is best in class, let's say, across that. So a very interesting and helpful guide that they update every year. In the solution space, where we're in the spirit of composite AI, the idea that we can do heuristics really well, we can do ML really well, we can do solvers really well. What happens when you combine them all together? That's kind of an area of investment for us now. Is how do you use ML to improve the solve speed of an integer program by maybe hand coding some heuristics that describe the parameterization of a particular solver, and then choosing among those heuristics using ML based on an ocean of data that we have across all our customers where we've used that solver in the past. So trying to sort of right now we have heuristics that solve things really fast, and then we have optimizers that solve things really accurately but slow. Is there a way that we can use ML not to replace the solver, to replace the heuristic, but to sort of bring the best of both into one space? And then the other area that we're not investing at all, let's say, is RL. So there's been a lot of recent fervor and advance in terms of using RL for like the traveling salesman problem. I think in the last 2 years, in fact, NeurIPS last year or the year before had like an ML for combinatorial optimization competition. So you're starting to see a lot of that hybridization of techniques to sort of augment the shortcomings of each technique independently. So, and RL is one of those areas that we don't invest in at all. And, looking forward in the next few years to start looking at how that can help us. We kind of want to wait for other people to mature it before we take it. We're kind of in that camp, but definitely keeping an eye on it.
Yeah, reinforcement learning, at least in kind of the academic papers, has made really big headlines solving problems that were really in the space of what you were mentioning of some of those either solvers or heuristics before. So it's really interesting to see how this technology can really move us forward. Maybe same question to you, Foteini. What are you really excited about but not investing in today?
So I would say that's the space of what we call in financial services alternative data. And so using image, video, language to make predictions is not something that we're too heavily invested in right now. The reason for that is because there was so much that could be already accomplished with the humongous data sets that we've already have available to us, that it was unnecessary as a step one to increase the data sets and bring different domains to it. But as you can imagine, these have direct applications, like when you are trying to model financial markets and reading scripts from conference calls or looking at data. There's a lot of satellite data that are extremely relevant for financial analysts that can come into modeling, and especially in equities research. So there's a very interesting space there. But again, when we first got at it, we realized that, number one, our businesses know how to derive value from the data sets that they already have. So bringing language processing to banking, when you're looking at problems like risk modeling, it's not clear from the get-go exactly how you're going to derive value, how that ties to the bottom line. And so that became a secondary investment. Also because in large enterprises, there are very big silos. And so even if we are modeling consumers, we may be looking at very different data sets for the same individual when they're transacting on a credit card versus a debit card versus applying for a mortgage or investing with us. And so we really prioritized bringing those data sets together and building stronger AI out of those rather than expanding the domains. But it's certainly something that is on our roadmap for sure.
Yeah, that makes a lot of sense. I mean, you want to take the low-hanging fruit first before you start foraying into areas where, Foteini, I think your audio might be a little bit funny. Before you start foraying into kind of more alternate data sources that, it's also, for a lot of these alternate data sources, it's not a given that it's going to add value. And so that's also why investment may not be as heavy there. So very interesting. Okay, so maybe switching gears a little bit, thinking just about the business case for AI investment. I'm wondering what has changed in the last 5 years. So probably AI was at really its peak hype, say 3 to 5 years ago. That's probably died down a little bit. I'm wondering, what have you all seen and has changed? And maybe we can start with Avi, because you probably see a lot of ventures coming through and their case, their pitch probably has changed in terms of what they emphasize.
Sure. Early on, somebody just saying, hey, they had cool tech and they were a recent PhD student out of Hinton's or someone else's lab could get them at least a round of funding and some excitement. Now, when we see the startups coming through the lab, they have to really understand what the tool is for. And so maybe one way to frame this is, if you have an AI company, a startup come through, and you ask them what their what they do and they say they provide insight, you should run. Because insight means they don't know what the prediction's for. They don't know what decision it serves. They don't know who it serves. They just say, hey, it's going to help somebody. And so where we see the opportunities now are much more when we go beyond, okay, this isn't about insight. Here's the decision that it's going to serve. And here's why it's going to make the organization better. And so, point one. And then the really big opportunities are to recognize that that decision is part of a system of decisions, and to reimagine how, okay, if we can do this piece better, how does that end up playing out through the whole system, through the whole organization, and create like a new opportunity to serve customers. It's not just an AI replacing a human. It's not labor replacing tends to be both depressing. You don't want to work on that, but more importantly than depressing, it's incremental. Where if you're using the prediction to create real opportunities for the organization, serve customers better, create new markets, develop new industries, that's where the excitement is, and that's where the biggest opportunities lie. And that's what we're doing next year at the lab, at the Creative Destruction Lab. Our AI stream is going to be focused on systems, and all these ideas they're cooked. Ajay Agrawal, Josh McGanns, and I have a new book coming out in the fall that's focused on AI systems and how to get us through these between times.
Very interesting. And so, the shift seems to be a lot less focused on technology to the actual business case, which is one thing. But from what I'm hearing, it's not just solving these point problems. It's really about how you can transform a business and provide an outsized growth and value. Very interesting. Okay, so maybe a different perspective, Nick. I know from our past conversation, it seems like you very always focused on the business. Have you seen much, like from your perspective, and how you make a case for AI? Has it really changed much in the last 3 to 5 years?
So I mean, for me personally, in my time with Assurance, no, right? Because we were have always been a tech company that was very data science heavy from day one. And so frankly, I would say our founders, if anything, were pushing our chief data scientist and myself to do more. And we would have to explain to them, yeah, I know you read that book or you read that article, but that's not the way that stuff actually works, right? It's actually super hard. Give us some time. So from that perspective, no. But it is interesting. I mentioned NLP is a big area we're moving in that I'm a little bit pessimistic about. To Avi's point on it's not just about having an idea. Over the last 5 years, we've dipped our toes in NLP on more than one occasion with someone who's hey, look, I can transcribe all the audio that you guys have, the hundreds of thousands of hours that you're bringing in every day. And it's great. We finally are partnering with a company because they nailed the workflow. And the particular workflow that honestly, I didn't even know we needed until I saw it. It's not super exciting. It's not sexy. It's call reviews, right? So again, we're in insurance and we have to review a bunch of calls, and we have a bunch of people that listen to the whole thing in its entirety. And what they have is they have a solution that you can define a series of phrases, moments they call them. We can inject some of our data science into that, but allows a call reviewer to basically review a call without listening to the whole thing. It flags all the key points. We're then also adapting it to use it for coaching so that a sales trainer can say, hey, Nick, you're underperforming. Let's grab all of your calls and let's go to key moments and let's talk about how you can do it better. But their transcription service isn't any better. Their AI isn't any better. They nailed the product. They nailed the workflow. They understood the business problem. And that's the thing that is making this tool is honestly making it so that we can take some of the core underlying parts of NLP and rapidly drive business value out from it. So I think Avi is spot on from what I see.
That's really interesting. And so your perspectives are almost from the customer's point of view about what these solutions can provide, and not necessarily exactly. From your business case. Very interesting. Waleed, how about yourself in terms of how the business case you're making to your internally in the company has changed over the last few years?
Yeah, when you're a tech startup, the margin, sort of the gross margin on revenue and its implication on multiples on a public stock market are not things that you really think about, right? So you're generally probably over provisioning and doing very inefficient things to get to an outcome because you want to satisfy customers, build a really good, cool product. once you're at a publicly traded, established tech software company that sells like SaaS software as a service, and you're not a web scale giant that makes incredible amounts of revenue on ads, there is a very, very, very hyper focus on gross margin and the infrastructure costs that could, either improve that or in many cases make it worse, are very difficult to ignore. And so I think one of the things that is interesting to see, because as public cloud adoption hits its sort of peak, and you start to bring in all these complicated workloads that haven't really benefited from optimization and efficiency, right? Because the main companies that are pushing the boundaries here don't really worry too much about gross margin because they sell ads, basically. So that's been a very, very important focus for us at Kinaxis, is very recently, is how do you get a lot more efficient? And that also informs the type of skills that you bring on, right? You start to need fewer data scientists and a lot more people who are very good software developers as it relates to sort of workflow orchestration and how to efficiently allocate workloads to infrastructure that you basically rent from public cloud companies. So that's been the major thing, is what is the infrastructure implication of these systems? And then the second thing is they are fairly complicated, although I would argue they are just as complicated as very, very complicated decades-old heuristics that you've been building over a long time and that are hundreds of thousands of lines long. What is the maintenance cost and the level of observability you need in that type of system in order to reduce the maintenance cost associated with this thing, right? Because once you sell something and you have a fixed license fee that you charge your customers, you need to ensure that you aren't also incurring a heavy burden having to sort of tune these systems to maintain them and to explain what's happening in them when customers escalate issues that aren't really bugs, but more they just don't understand how the software works. So those are the kinds of two pieces that are sort of entering into the business case and the economic models that we're building to understand the profitability of what we're doing. And I'd be interested to see how this evolves over time as it becomes table stakes, not for web scale giants that sell ads at a 1 billion% profit margin, but for run-of-the-mill software companies that sell tools and solutions to end users and have to absorb a lot of the hosting costs associated with that.
That's interesting. And when you're in a very boom period where money is just flowing in, typically you can ignore a lot of those things like profitability, infrastructure costs, and whatnot. But as we're coming out of that period, really the business case starts taking over. The financials of whether or not this kind of investment makes sense is really important. And
one thing I would say, Brian, is from a CDL perspective, I'd be really interested to see, because there is a white space there in terms of tooling that automatically optimizes certain types of workflows for cost, and some sort of like I should write this down because maybe I should go start this startup. Essentially, sort of like a whole other section of that data infrastructure ecosystem that just doesn't just tell you are bad at optimizing costs, but actually starts to do some automated cost optimization for you, and it starts to get into the internals of your system to do that. That's a white space, I think, that's yet to be worked on.
One other point, just to riff on that, Waleed, is I haven't really seen any substantive AI development in data lake ETL. And for context, infrastructure matters to us. Half of our cost since day one has been related to our data lake and ETL and data transformation. And no one talks about it. It's just like, oh yeah, it's expensive. It's worth it. But like, there's a ton of customization of like, oh, well, I need this exact metric for this reason. And it requires deep domain understanding of the business. And I actually feel like there's a lot to be made in that space.
I've been simmering on that exact idea for a very long time. Brian can probably attest to that. Trying to get researchers to work on a very unattractive problem, which is how do you automate the extraction, which isn't so hard, but the transformation, which has so much semantic and domain knowledge in it. That, yeah, I've seen attempts at it in the past, but it's a very hard problem. But if somebody can crack that, oh man, that's a big problem right there. Yeah.
Yeah, there you go. I mean, for those listening, a startup idea for yourself. I know, Foteini, we have a lot of data problems of our own at Borealis, and Borealis, I think, is only 6 or so years ago. So I'm wondering, like, in terms of the investment case that you made to RBC and to start up Borealis compared to where we are today, what is the difference you're seeing?
So, well, in terms of infrastructure, I would actually echo everything the team just said here. It's really understated what of a task it is to get this done properly, and it's a stepping stone. Like, you can't really do anything without it, and it's extremely expensive as well. Then, in addition to that, investing in high-end computing resources, whether that is public cloud or on-prem infrastructure, maintaining all that is an ongoing job, and you really got to plan for resources for that. In terms of how our perception of delivering value has matured over the years, once we've gone through the cycle a number of times, and remember, we come from R&D, right? So we start with business problems that don't have immediate answers. You got to go usually back to science, solve something there that wasn't accessible otherwise, and then come apply it in the business. So it's a longer life cycle, but we've gone through it a number of times now, all the way to product launch. And what we've learned is to ask the hard questions up front. So we used to think that you should keep the two separate. So business and practitioners should be in one side, and then you got the tech teams and the researchers on the other side, and you got to give them air cover and protect them so that they can solve these big problems. But there were so many missed opportunities if you do that in isolation, in understanding really how that machine learning is going to be deployed, starting with properly formulating the problem. And the devil is in the details, right? Like, you think that you heard some business person tell you, this is the problem I have, but I can translate that usually into 10 different ways I can approach it with AI. And finding the right one is not straightforward, because if I get it wrong, it means that down the road, the business is going to have to adapt how it measures value. And most likely that change management is not going to happen. And usually this is where tech gets shelved. So you've got to be really careful earlier on about aligning with what exactly we're solving for, where the bottom line is. Also understanding the entire pipeline of that integration, especially in what we do is literally B2B, right? So we're building for the bank, we're integrating into the bank, although we're sitting outside the bank. And so it's integrating into systems that have been there for hundreds of years is definitely not straightforward. And so understanding what kind of real-time support, what kind of feedback we can get from the user so we can retrain the algorithms early on is super important. And of course, speaking with your risk groups and regulators early on. You really don't want to get to the finish line and then realize that you just don't meet the bar for what's acceptable to launch your program. So understanding that investment earlier on, because there's a lot of scrutiny again that goes into the systems in financial services. Validation of our algorithms is something that we plan for at least 6 months in our development roadmap. And that's, if it's internal validation, it can be external validation as well. And understanding all these things, and like even smaller things, like if I need to update my algorithm down the road, which you should, like a machine learning is a living system. The environment where it operates will change and it needs to adapt itself. What do I need to do then? Do I need to go back and revalidate everything, re-engineer the system again? So you got to be very clear about these things earlier on. And we've found that we can be more successful with doing all this homework at the get-go.
Yeah, that's a really good point. And kind of two themes that I'm hearing through this is one is really integration into the business is kind of a must now if you want to, through experience, deliver a solution that actually provides value at the end of the day. And then the other one is really take into account the full cost of this life cycle of things. Of course, the infrastructure, the time, things like validation or with the regulators signing off, which are not insignificant. They're quite significant in terms of costs. Okay, so we have a couple of questions from the audience. So maybe I'll turn to that. One of the first questions we have is, I guess, for Avi. He's the person is asking, how can changing the regulatory landscape have a positive impact on bias in AI? So maybe we'll start with Avi, and then if anyone else wants to jump in, we'll let them do so.
Okay, that's a great question. And I could give a 4-hour answer, but I will try to make it a 40-second answer. Where right now our regulatory system is biased toward no change. And so you get punished if you do something different and something goes wrong. You don't get punished if you keep doing what you've been always doing. Okay, always been doing. And so, for example, if you have an HR department that's extraordinarily biased and that you never hire women, no one will know that and no one will care regulatory-wise. If you bring in AI to try to improve it, well, now you have a metric that shows that, and that's auditable, that says, hey, you're not hiring enough women. And now you're liable in a way that you would not have been before. And so Alberto Galasso, one of our Rotman professors, has some research on liability in medical devices. A little bit different, but same kind of idea. And what he shows is when the liability is focused on if you do something different and something goes wrong, then happens, we don't get a lot of innovation. Alternatively, if the liability is, look, if something goes wrong with a patient, that's bad for you, regardless of whether you did something new or whether you did something that you've always been doing. When the liability rules look like that, then we tend to have innovation, and that innovation focuses on safety. It's exactly the kind of innovation we want. And so that's just one example of how the way we design our regulatory infrastructure guides innovation. And if the current regulatory infrastructure around AI, especially around bias, is if you use it, you're in trouble, and if you don't use it, you're not, well, people aren't going to use it. And that's the problem.
No, that's really interesting. Does anyone else want to comment on this idea of regulation?
I can jump in. I think indeed there's been a bit of a delay in the regulators coming to the table, but to their credit, I've seen a lot of advancement now in the financial services space with steps like approaching banks with getting our perspective on how they should be regulated, and then creating that common denominator, like what makes sense for the industry. And I think one thing that can come out of this is I don't think that explainability solutions or any of this will come out of regulation. I think what it can help establish is a common shared benchmark and understanding for what fair is. Because that really doesn't exist today, and it's open to interpretation for most businesses. So how should I test a model? When do I need to test a model? Do I always have to do it for any type of model? Are some that are higher risk than other? Environments that are more sensitive than others? So having all that standardized will be a great first step that can come from just a dictation from regulators.
Very interesting. Anyone else want to jump in? Okay, so we don't have a lot of time left. So maybe what I can ask for everyone is, throughout this discussion on AI, or how you're thinking about AI, what is like really the biggest lesson that you've learned in all your time in this industry? And maybe you can just keep it at one, and let's do maybe a round table, 1 minute each, and then we can wrap this panel up. Let's start with you, Waleed. What's the biggest lesson that you would say you've learned?
Lessons, I would say, and we continue to learn lessons. And sometimes we seem to learn the same lessons over and over again, and not really seem to take effective action at them. So again, I would just repeat that my perspective is coming from like a product development, software as a service lens, and from that perspective, I think the biggest lesson, and the one that we seem to keep learning over and over again, and I don't think anybody's quite gotten this right yet, but we will eventually. It's a function of time. Is when you're building from day one, like you start to you know what the user problem is. You have a TAM identified. You kind of get a sense of how you need to construct your system. Is to build for scale and repeatability from day one, as opposed to sort of have janky components stitched together. Opt for simplicity, but scale and repeatability, so that you can add complexity later without having to then overcome a lot of technical debt you may have incurred to sort of get to scale and repeatability. And that's from my lens, which is how do you get something that you build as generic as possible. Again, VCs love to hear that, right? It generalizes, everything generalizes. And I think it's less about the algorithm itself generalizing and more about the entire system being generalizable, and having a very good understanding of the interaction points in between, and the types of user personas and skills required to either implement it, to maintain and sustain it, or to use it as an end consumer. So I think having a very clear vision around those pieces and building it in from day one is the biggest lesson I've learned. What complicates that lesson is that, as I've mentioned earlier, the ecosystem of tooling is still evolving across that entire chain. And so you end up being saddled with decisions over time that had you made them a year later, you may have chosen to do something very different, because some technology would have matured even in that 1 year time frame. I know, Brian, you and I have talked about that in terms of decisions we made 5-6 years ago, that had we waited a year, we would have done completely differently. So just making sure that you have a strategy to live with those decisions, to live with that sort of debt, and deal with it over a longer time horizon than just 6 months, but over 2-3 years. That's kind of the largest thing that I would say.
That's a really great point. And maybe just quickly on the other, so we can get everyone in. Nick, quickly, like what is the biggest lesson that you've learned?
The best decision that we've made regards to AI and ML was the creation of a machine learning engineering team. And people don't always understand what that means. For us, it's a human interface layer between a data scientist and a researcher and the actual engineering world. And I think, why is it so important? I found you do have people that we call full stack data scientists that can do a little bit of all of it, but frankly, they're not great at any of it. And for us to have the most business impact, I want a product-oriented thinker in the data science and research world who zooms out, thinks really big picture, can tell a story with data, find real problems, and frame them into mathematical solutions. That person is rarely also really good at taking that into a production environment, thinking about how to get the data going, how to have well-structured code, how we're going to deal with repeatability and failing and scalability. And so our machine learning engineering team, it sounds exciting and it sounds sexy because of the name, but frankly, it's a group of engineers that can talk to a data scientist and understand their world and bring it into the production environment. And it's frankly a human interface layer that's been really critical for us to be able to move fast. Whereas if we had data scientists embedded across all the engineering teams, most engineers don't know how to talk to that data scientist and understand them.
Really, really good point. Something that I've experienced as well. Foteini, really quick, what's the biggest lesson that you've learned?
That you cannot go fast and break things. This not only because it's a tedious process that has a lot of steps, but also because, for heaven's sake, we have a shared responsibility here to not mess up society further. And there's been way too many instances of products getting retracted because, hey, we didn't really expect that it would work this way. We didn't really have a plan for it. We haven't tested for bias here, privacy there, or whatever that may be. You got to be very careful about this, no matter how big or small a company is, no matter how large or small data sets they handle. are, things can change over time, and that impact, you just can't take that away. You can't undo things that have been done. It takes one bad player to ruin consumer appetite for AI.
Yeah, very, very good point. And then lastly, Avi, what's the biggest lesson you've learned in your time in AI?
That point solutions are useful but incremental, and the big impact is going to be when we can figure out system level change.
Very cool. Great thought. And with that, maybe I'll just quickly pass it back to Ryan to wrap up.
Great. Thank you, everyone. Thank you very much to our panel for their time and contributions. I'm sure our audience has learned a lot. I know I have. So I just want to close by mentioning, please join us for our next event from the Data Lab. Your Computer is on Fire on May 17th. We'll be joined by Janet Abbat, Mar Hicks, Kavita Phillip, and Srila Sakar to discuss the societal impact of inequality, marginalization, and biases that are found in our technological systems, a topic that we discussed here today, and we're going to discuss more next month. This event is part of our Gender Analytics Possibilities series, co-hosted with the Institute for Gender and the Economy. So we hope to see you there. So thank you for joining us today, and everyone have a great day.
Thank you.